Alrighty. I am gonna go over number two on the rate in, rate out FRQs. Be sure to watch number one first, just so that you know what I'm doing. Remember that this is essentially a game called plug everything into the calculator and interpret what each question means. So I'm gonna go a little bit faster for this one, and plus I already pre-typed everything into the calculator, so this one should go faster. But be sure to pause the video if I'm going too fast because like right here, I already have the two functions of m of t and s of t onto my calculator already with y2 minus y1, aka my rate in which there is the total snow. Obviously, you want to read the stimulus first on what I'm saying because you're going to be confused if you don't read this first. So probably read this first, type everything into the calculator, and then we are going to work on these four problems. So for part A, it says how many inches of snow will melt during the 5 hour period. You know that m of t melts, and it's given by that function right there. Now you will notice that m of t is in inches per hour. Part A says how many inches of snow will melt during the 5 hour period. So obviously we're going to take an integral. So from 0 to 5, m of t dt. Now m of t dt, remember that's going to be this first equation right here, first function, 3 pi times sine of pi of t over 12. So once I do that, I'm going to go to math, f nth integral, and then I'm going to do 0 to 5. That function was y1, and then I have dx, which will give us about 26.6825 inches of snow that will melt during the 5 hour period. Part B says express the total depth of the snow in inches at time t as a function defined by an integral. So we have a of t, and then we're going to include my 6c because that is my starting point, plus the integral from 0 to t of s of x minus m of x. Remember that s is we're adding, and then m is subtracting because it's melting. And then, of course, we have dx. Now, the reason why we have this is because whenever we use FTOC and we take the derivative of this, we're going to have s of t minus m of t, which should make sense for part C, because if we're going to find the rate of change, that's just the derivative, the rates. Notice how m and s are both rates. So here, to find the rate of the change of the snow depth at time is equal to 5, I'm going to have s of t minus m of t, or s of 5 minus m of 5. Okay, so that right there is going to represent y3. Remember that s represents y2, and then m represents y1. So we're adding, which is y2, and then we're subtracting, which is y1, so we get this lovely thing. And we want to find out what happens at time is equal to 5. So I'm going to go to second table, and at 5, you're going to see that we have 6.9964. 9964. Okay. Now, it doesn't tell you to justify, however, this is going to be good practice on justifying. So this is essentially saying the snow depth at time is equal to 5 hours is increasing at a rate of 6.9964 That's all we're doing for part C. Okay, for part D, from 0 to 5, at what time t is the depth of the snow a minimum? And we want to justify our answer. So before we do that, we need to find my critical points of a prime of t. And essentially that's when this is 0 right here. And at that 0, that's essentially when s of t is equal to m of t. Or when s of t minus m of t is 0. Which is helpful because that's essentially y3. And essentially what we're going to do is remove all of this, because the only graph that I really want to look at is y3 from 0 to 5. Change your scale so that it doesn't look stressful. You want to be as close as 0 as possible so that when you look at it, it's, you can actually see it. So here, I know that this is about what? 1, 2, 3 point something. Let's find that 0. Figure out what that 3 point something is. Oops. There's my left bound, and here's my right bound. So you can see that I have a 0 at 3.935674. Now the reason why I'm having so many decimal places is we want to be as accurate as possible. They like 3 decimal places, however, use more than that just for accuracy. Now, if I want to find the depth, that's going to be whatever we did for part B here. And just like how we did in video 1, I'm going to go to second window so that I can look at my table set. And I'm going to set my independent as ask, so that whenever I do the integral on y4, oops, I do not want to graph that. I could just type in the critical points. So I could type in 0, I could type in 3.9, 3, 5, 6, 7, 4, 4, and then I could type in 5. And here the question is asking us what's the depth of the snow, and of course, just like the first video, I forgot to include my initial value of 16. Oops. Okay, so where is it a minimum? Well, that's going to be at 3.9357, or the thing that we just said. And then that's going to be 51.45716. Whenever we are justifying our answer, this is essentially saying the depth of the snow attains a minimum at time t is equal to 3.935644 hours, in which there is 51.45716 inches of snow. And that is your little justification. All right, so that was number 2. In the next video, I'll do 3 and 4. It's essentially the same thing, so I don't think you'll need 3 and 4 that much, but it's there for you if you need it. Try it on your own first before watching the video for number 3 and 4, just because you should be able to do these on your own given these 2 videos now.